Hello, everybody. It's so great to see you all. Good evening, or good afternoon, or good morning, wherever you are. So yes, my name is Carly. Today, I'm going to be talking about building search experiences. Here we go. Let's share. Can people see slides? Can I get a thumbs up? Wonderful. Thank you. Okay, so I'm going to talk about search experiences. So we're going to talk about traditional lexical search and just basically how it works, vector search and what the difference is and why you would use one over the other. And we're going to use both of these to build a little web app. And then there's an extension section at the end where I'll show you, if we've got time, how you can incorporate a large language model to generate responses off the back as well. Questions absolutely encouraged. I will do my best to try and keep an eye on the chat. If you're comfortable coming off mute and asking a question, that's a-okay too. If you want to ask it in the chat, I'll still keep an eye out. And there's no such thing as a silly question, especially if you're new to search, not just coding. There's a lot of very specific nuances. I'll probably end up using a whole host of jargon that you've maybe not heard before. So just please do call me out and say, what does this particular word mean? Or can you explain this in a different way? We've got plenty of time for questions. But let's dive in first. So you can either follow along or you can just kind of watch away. It's all absolutely fine, but I should probably introduce myself briefly. So my name's Carly Richmond, as I said. So I'm a senior developer advocate at Elastic. Before that, I actually worked in investment banking as a software engineer for 10 years. So I've done all sorts of weird and wonderful jobs. I'm lucky enough to be a speaker, and I also get to write cool content on my personal blog too. Obviously, we've said questions are absolutely encouraged, but if you're following things after, or you think of a question afterwards, you're like, I really wish I'd asked Carly that. I'm on X, I'm on Mastodon, I'm on LinkedIn. Feel free to DM me, or there's a contact us form on my page as well. Always happy to chat about anything to do with search, tech, public speaking. So feel free, don't be shy. Right, so we're going to talk about Elasticsearch today, and we're going to see a bit of Kibana. So you'll hear elk stack a lot when we talk about search, and basically elk stack is three elements. It's Elasticsearch, which is a distributed search and analytics engine. So it allows you to ingest your data and perform searches that are kind of performant, over that data. And we'll talk about how it does that. There's Logstash, which is one of the many mechanisms you can use to get your data in. You don't have to use Logstash, but that's a common use case, particularly around logs. So if you've got a particular application you've built, or maybe your machine is generating logs around your accesses or the things you're typing in the terminal, it can pick those things up. And then Kibana is the UI. We can build data visualizations and things like that in there. We can see what's going on, and we'll be using the DevTools segment within there to actually run some queries. So that's how we're going to see things today. So this might get a bit in the weeds, so please do kind of stop me if it's not clear. But the reason that we say that Elasticsearch is distributed is because it's split as separate layers to try and make sure that we break up the problem. So in computer science and tech, it's very common to try and split problems into smaller pieces and try and run things in parallel to try and get the overall execution time down. So the way that Elasticsearch is structured is you have a cluster, which I have a toy cluster that you can play with today. I'll share the credentials in the chat in a minute. And then within that, there's multiple nodes that will perform particular operations. So they might be, perhaps just focusing on bringing data into Elasticsearch. They might be doing the search operations, all sorts of things like that. And then within there, you will have an index that's split across what's called multiple shards. And that means that when you're trying to search for something, you'll search across all of the shards, find the results that are relevant, and then merge everything together. So hopefully that makes sense. If it doesn't, please feel free to plonk something in the chat and we can go back through. Okay, so this is what we're going to build today. Just a really simple web app using some JavaScript, some HTML. I'm not going to cover the CSS bit today, just because it's something that's already available in the starter app. If you've got questions on the CSS though, I'm happy to answer those too. So feel free to plonk them in the chat. And then what we'll do is we'll send off our questions to a little JavaScript server. You quite commonly might use cloud functions instead, but we're just going to keep it simple and have a server today. It's going to send off the question to Elasticsearch, and then we'll get the documents back that match, and then we'll use those to generate these recommendations. And if we get time, we'll extend it and we'll do an AI generated little feature review. And I'll show you how you can do that using my own OpenAI token. And if you want to give it a try later and you get stuck, don't worry, you can ask me questions afterwards. It's not a problem. But the way that that bit works is, in addition to getting the documents back from Elasticsearch, we basically send the documents as a prompt to, I assume people have heard of ChatGPT, large language models. Yes. So we send it to a model like that, and it will generate a natural language response using those documents. And that's called a RAG architecture, or retrieval augmented generation, if anyone's interested. Right. So there are some prerequisites that I'm going to cover quickly. So if people want to follow along, I have a starting point application for you, and it's available in GitHub. Okay, so I'm just going to put it in the chat. So within this, it's got all this is the data that we're going to ingest is in this folder. I've got all the diagrams that I've been talking through today that are in my slides. The slides will be in here as well. I just need to update the latest ones, but you'll be able to see those later. And then I've got all of the lab sheets. So all the instructions that I'm going to follow today are in here. So if you want to go back and try it again, or you're following along online and you want to double check something, they're all in there too. This is the starting point app that you can use and build on top of. And then if you get stuck or you want to see how I did it compared to how you've done it, you've got the solution app as well. And within solution app, you've got 3 stages. So there's the basic text, the hybrid, which is the vector and the keyword together, and then a RAG extension. So all the code is there. And if you have questions, you know where I am afterwards. Okay. So the best thing to do is either, I would fork it personally, if you're familiar with GitHub forks. If not, that's okay. Or you can clone it locally, just maybe don't push the changes up. And you can start working along from within that, okay? So if you're working along, that's the stage that I would recommend doing just now. Okay. The other thing is, because we're doing JavaScript development, there's 2 other things you normally need installed on your machine. So you need Node and you need NPM. If you've done anything with things like React or Angular or even vanilla JavaScript, you've probably got these installed already. So if you just do Node-V and NPM-V in a terminal, you will be able to see if they're definitely installed, because it'll come up with an error if they're not, and it'll come up with a version like this if they are. And there's this link here as well about downloading and installing. So what I can try and do is pull that out for you in case anyone wants to double check just now for their installation. So, we're flipping things around, but that's okay. Here we go. So that's the link that I was just talking through if you need to know how to install those. There we go. Okay, cool. So we've talked about the project structure, so we'll not go into the details of those, but we'll talk about what the elements are in the starting app so you know where things are and where our code is going to go. So we have the server.js, that's the Express server, so the little JavaScript server that's basically sitting in the middle between our front end and our Elasticsearch cluster. You've got the index.html, so that's the view of what your page is going to look like. So it's going to have our buttons and all of our elements that the user will interact with in the browser. You've got the style sheet, which is what we do to position things and make things look pretty and change the colors and make sure that everything is as we want it laid out on the page. And then you've got the code behind for the JavaScript. So if you have a button, for example, that needs to do something and trigger a dynamic event, you would write the function in the code behind and then import that in. And I'll show you how we've done that when we get to that point. And then just to make it easy, I put the Elasticsearch stuff out in a separate JavaScript file just to keep it separate from the view of my index.html behavior, just to keep it right in my head. So if it got more complicated or my files started to get really big, I've got a logical separation. So hopefully that will make sense so far. Right. So first things first, we need to get some data inside Elasticsearch so that we can actually search on it. And so we can end up having results coming back into our UI. So I've got Visual Studio Code as my IDE. Whatever IDE you're comfortable using that's for JavaScript. So there's things like WebStorm, or even you could be writing things in a traditional text editor. That is A-OK. But what we're going to do now is we're going to try and ingest the data. So the way that we're going to do this is really simply just by importing a CSV file. So a CSV file is just comma separated. It's something you can export out of spreadsheet applications really easily. But where I've got it from is a site called Kaggle. So has anyone heard of Kaggle before? I'm seeing some nods. Wonderful. Okay, great. So this is a good source for data sets. I will talk about Hugging Face later that does have some data sets, but Kaggle has some pretty good ones that have been around for a long time. And this one I found is Popular Movies of IMDb. So if you've registered for an account, what you'll see is you're able to just download it. But I do have a little shortcut for you because this file is available in data, just to make it easy so that you don't have to now go in at this point and register an account if you're following along. So we are going to take this file and we are going to upload it into Elasticsearch and see what our data looks like. So the first thing you're going to need is you're going to need to be able to access my Elastic cluster. So that is the location of my Elastic cluster. Now, if I've done it right before this call, you should be able to log into that without needing to put in any authentication at all. If you're not, this is the moment of truth where we find that it goes a bit wrong. Someone's told me it works. Thank you very much, Ketchy. Wonderful. So if people are following along, you can do that. So this is Kibana that I was talking about at the front end. Okay, cool. We've got 2 people in. That's really good. So this is the menu bar. There's all sorts of things in here. We could do several hours just talking about everything that's in Kibana. But the things I want to point out is you've got Discover, which is just a really simple view where you can go and look over data, which obviously I can't because I've not got any data in here yet. We've got the DevTools, which we are going to use for querying, and we'll talk about that when we get there. But the thing that we want to do at the moment is adding data. And the simplest way to do it is to upload that file using this upload a file option. So I click in, I'm going to select the file from my data repository. And you'll see that it's analyzed the contents of the file and it's figured a few things out for us, which is really cool. So it's figured out the character encoding, which is fine. Elastic can support multiple different types of files. So it's figured out that it's not a non-delimited JSON, sorry, new line delimited JSON, because it tried to parse it in the parser through an exception. It also had the same thing with XML, so it's figured out that it's CSV, which is correct. It's trying to figure out what the types are for particular fields, and it's also doing things based on the length to try and figure out if it's got a header. So it does a lot of analysis to try and make sure that you don't have to specify lots of stuff. So here it's picked up all of my field names. So it's also picked up particular like data types. So it's figured out that this column 1, which is just a simple number, so it's the row number basically, so that it's figured out is just a number. It's figured out that original language is a keyword. So in search, it's a bit confusing, but you can have a keyword type and a text type. And the difference is that a text field is what you do for text analysis. So it'd be like maybe a long stream of text that you'd maybe pick out particular things from. And keywords is normally like a unique identifier, such as an email address or something like that, that you might want to aggregate on. So that's the difference between those. Hopefully that makes sense. And then it's figured out the vote, average, and counts are also numbers. So that's pretty smart. I'm just going to override the settings. So I'm going to change column 1 to ID just because it kind of makes sense. And you'll see all the things it's figured out, like header, row, and things like that. Is anyone else seeing this? So you are only seeing analytics. Okay, that's interesting. So I see Celia and Agnes, have you got that? You've all got that. Okay. What we're going to do then is quickly give you all permissions with responsibility to make sure that you can do what you need to do. Okay. This is where I have to think about it. Not there we go. Okay, cool. And it's a codebar attendee role. Okay. So I'm going to give you all, just to be on the safe side, to make sure that we can do what we need to do. And update. So you might need to do a refresh, but hopefully, if I've done that right, you'll see something closer to this. So if we give it a refresh, we'll see if that's given everybody the permissions that they need. Okay. Now you can see some extra things in the hamburger menu. Well, that makes me feel a bit more optimistic. Is anyone else able to see more? Farhath? Still the same. Oh dear, I'm not going to figure this out. Okay. Analytics and management. Right, so let's figure out if you've got everything you need. Can you see DevTools? You need permissions. Okay, so that's good. If we can see DevTools, we can do querying. So we'll all just use my index for doing the queries if we're cool with that. Cool. Okay. Awesome. Right. So we'll do that then. That's fine. So what we're going to do is we're going to, oh, no. That hadn't got my old field name. Cool. So let's do this again. So I want to override the settings and change it to ID. I'm going to import. And I'm going to call this movies Carly Richmond. So this is the index that we're all going to use, okay? And we need to create a data view because that's how Discover and the Kibana stuff can sit on the top. Cool. So that now says that that's been created. So now we're all going to check if we're able to query. So if we go to DevTools, you should see something like this, but it might have a query on it. But the idea is that you'll see two panels. This is where the results are going to show. Ketchy's seeing it. Wonderful. Okay. So now what we're going to do is we are going to try and run our first. We're going to run our first query just to check. So just to confirm the index is there. So this is me against this index getting the mapping. So this will show me the data types. So you can see that it's ingested that property ID of type long and all the other ones, language, overview, title, and the votes, they're all there. So I want you all, I'm going to ping this in to the chat to try running a query like that. So while you're all pulling that up and getting your DevTools console ready, I'll paste it in. So this is the simplest query that you can do. It is called, so it uses the search endpoint against the index. It's a query and it's what's called a match query. And I did have it up at one point. So match query, Elasticsearch, there you go. So it's basically simple. It's going to do an exact match because that's what traditional lexical search is. So I have an example in my slides. because we talked about why it's fast. And one of the reasons it's fast is because we're not looking through every document that we've uploaded, okay? We are basically taking the document and processing it and turning it into what's called an inverted index. An inverted index just means that you've got all the kind of useful, interesting terms. So we'll strip other things out that are not so interesting. And then you'll have a reference back to the document or the page number effectively where it exists. So if you think about the index of a book, it's the exact same kind of construct. So quite often we'll do character filtering. So we'll remove things like maybe formatting of HTML characters because they're not useful. They just show the structure of the page, not the content. We'll split it up into tokens, which you can use different tokenizers depending on things like which language the text is in, for example. And then you also have token filters. So for example, if we didn't do token filter to change everything to lowercase, and we looked for star with a capital S and then star with a small s, it would look for exact matches with the casing. So sometimes we can do smart things to try and make sure that it's going to pick up the right thing. And that's what we do with the token filters, giving us something that looks a bit like step 3. And then that document is what, that structure is what we're going to search over. So where's it? There we go. So we have this match query. So if you paste it inside the console, and then you can either hit this little play button, or if you're like me and you're a fan of keyboards, you can press Control Enter or Command Enter, depending on whether you're Windows or Mac. And you should be able to see the results that have come back. So are people able to run that okay? Is that giving them any results back?
Yeah, quick question.
Uh-huh.
So I've got this query like match title called. So you get that hits total value 14. So that means there's 14 matches where the title
Yes.
is called. But I'm seeing in the hits list, I only
Yes.
have 10. Okay, you're getting to that.
You have asked a really good question and you've given me a great sideline into why.
Okay.
So thank you. It's a brilliant question. That is the default setting because when you're doing search in these systems, you might have potentially thousands or millions of documents. So you might want to know, yeah, you figured it out. You might want to only kind of return back a short number of results for things like paging. Or you might also have the situation where you just want the total number of results. So there is an attribute that you can add on to your query called size. And this will allow you to tweak the number of results. So you've correctly pointed out that the default is 10. So if you now specify 14 as the size and run it, it should give you 14 if we count it correctly. So that was a really good question. Thank you.
And is there any value for size where it just gives you the value of the total hits? Like you don't know how many hits you're going to get, but you just want all of them.
Yes. So that's a really good question. So what you would normally do is you can do scrolling searches, which is what you would do in the instance where you have lots of results that you're wanting to come back. So in that particular, you would either set like a really artificially high number, or you would use a scrolling technique to get them a bit at a time. Does that make sense?
Yeah, and I suppose you'd do pagination on your front end anyway, and then
Exactly.
yeah, okay, well, little by little.
Yeah, exactly. Cool. So yes, so as we've correctly pointed out, adding in size will then tweak the number of results. Right, cool. So let's try something a little bit more complicated. So this is a simple query, but you have a construct of something called, as you'll see from the DSL documentation here, a compound query. And these are basically combining multiple different ones together. And the one that we're going to do, which is the most common, is called a bool query. Okay, so this is in lab, if people are following on in the lab sheets, it's lab 2, but here is the bool query here. So what you've got is basically these 4 types of clauses. So there's the must, which is where you'd put a query in to say what, what matching documents will contribute to a score, because the way that we're looking for things is basically Elasticsearch will calculate a score as to how relevant your document is, and then it will return it. You have filtering. Now, the difference between must and filter can get a bit confusing, but basically this allows you to filter out results in advance. It's good for caching. So if you're running the same query all the time, having the same filter over and over again means it will kind of cache the results early. And it doesn't basically take into account in the score. There's the should, which is kind of optional. Good question on the score. So the score is basically a value that says how relevant that document is to the query that you've sent. So if we go back into the console again, you'll see that each document has this underscore score, which is sitting in there. And that basically is calculated in the depths of Elasticsearch and was seen to basically say how relevant this is. So this is basically saying that this document is considered the most relevant because it's got this particular score. But interestingly, the next one has a similar score. But if we went down hypothetically, we'd find things, see there's a score of 3. So that document is considered less relevant, and it's based on the matches, but it's also based on things like where in the document it is and things like that. So Ketchy, I hope that answers your question. Cool. Right, so let's do this bool query and see what we get. So you'll see that I'm saying it has to match title code, but I'm also saying that it should not be in EN. So these are language codes. It's the 2-letter language codes that you quite often see when you think about localization and things like that on websites. So you see when I search these, I'm getting a different set of results compared to before. So I'm getting some English results and some other languages like French. And you see I've got 14 hits here, but when I run the Boolean that excludes English language, I've only got 3 coming back. So you can basically build super complicated or super simple queries as you go. So we want to add this into our web app. That's what we want to do next. So what we're going to do now is start our skeleton application and see what it looks like. So this is me having it downloaded. If you're following along, what I'd recommend is just move into this directory within the terminal, because we'll be using the terminal. So if I go into CD starting app, you'll see that everything's in here. So all those files that we talked about before are there. And just to show you what's there in terms of libraries that we're using within JavaScript, you'll see I've already downloaded the Elasticsearch one for you. There's also cores, express, and path. Hopefully that's what you're seeing. If not, if any of those are different, just let me know. But if anything's missing, what you can do is npm install, and then the name of the library. So if I wanted to do installing Elasticsearch, yes. So for that one, you'll need to do Elasticsearch. So if I copy this and plonk it in the chat, you should be able to run that and see if that's okay. Okay, so that's why I was doing changes earlier today, because I was checking to make sure things work. Okay, so we're going to discard. Nope, I'm going to keep you. I'm going to discard you to make sure that I am in the same stage as you. Discard. Great. Okay. So now if I go into package.json, that's how it looks without, yes, thanks, it worked. Fantastic. So I'm going to do npm install elastic/elasticsearch, and you'll see that's added on. Now, the other thing I'm going to call your attention to in the package.json is the scripts. These are quite often commands that are shortcuts to do things like start up your application, run the tests, things like that. And I've added in a start command, which is basically running the server. So if you do npm run start, once you have all of your, you might have to do just npm install fully to make sure that your node modules has all of the dependencies added in. Because if you've just run Elasticsearch install, but not all the other ones, that bit might be missing. So if you do npm install, just to make sure everything's running, and then we can do npm run, saying that we're going to run a script, and we run start. And hopefully you should see, you won't see debugger attached because I'm running in my debug terminal. So actually I'll stop that so I'm mirroring what you guys are doing. Start. You'll see recommending movies on port 3000 in the logs, if that's working. Great, it's running. I'm loving the feedback, thank you. So now you need to navigate to that site within the browser. So localhost 3000. And if you navigate to that site in your browser, you should see this. So it's not doing anything interesting yet. It's all just static content. And we're going to add in search results and make it do something interesting. I've just got my console DevTools at the side. So for anyone who's not familiar, Chrome has some really good internal tools for debugging, checking out styles, looking at the performance of your website. It's got Lighthouse for different metrics, all sorts of wonderful fancy things in here. So that's worth having a play with as well. But in order to do our web app, we need to add some code. So first things first, we need to do, so I'm going to recommend at this point that you use the steps in the web app script because we have some quite long snippets. So in the lab sheets rather, I'd recommend having a look at this sheet here specifically. I'll do my best to paste the code snippets into the chat, but you might find they get a bit wordy. Cool, so let's do that. So the first things first is we want to add in the view to our HTML for some controls. So we're going to have two things. We're going to have just a simple input box where we can enter any text we like. And then we're going to have radio buttons for each of the languages that potentially want to filter our movies by. And we're going to have a button, recommend movies button, so that we can actually trigger the response when we're ready. So what you'll see in your index.html is input controls and a to-do. So you need to replace the input controls with all of that content there. So it is, my message is too long. So sadly, what I recommend is going into that sheet and you need to paste in the code from step 2, and that will get you what you need. And remember to make sure that it's input controls that you're replacing. So that will give us a view. So if I now, because it's the HTML, I don't need to restart or anything. But if I refresh this, you'll see now I have that text box and I have my language filters, which is cool. So, but what you also see, actually console do it for me. If I click, you'll see nothing's happening. It's not actually doing anything. And the reason for that, if we go back to the view code, is because this button doesn't have an action. So we need to register the click event for the button to do something interesting. And the way we do that is by basically passing in a function. So what you need to do next is you need to change your button code to add in an on-click event. So you'll need to add in that on-click equals get recommendations, which I've pasted into the chat, but you'll be able to see it here as well. Now, do we think this is going to work yet? No guesses?
Well, we need a get recommendation function somewhere that's going to do something. Unless it's
Yeah.
already there, you get the whole file.
You've exactly got it. We've not defined the function yet, so it's not going to be able to find it. You're absolutely right. So now what we need to do is something interesting. We need to add in the actual steps for going to get our results. And there's a few steps to this, so just bear with me. So we've all done the installation of Elasticsearch. What you also need, though, is you need credentials in order to authenticate the request for the between the server and Elasticsearch. So what we'll do is we'll start from Elasticsearch and work backwards to show all the pieces connecting together. So I have credentials for yourselves for the particular instance that we're connecting to. And hopefully this should give you the entitlements you need. So there's two things that you need as environment variables. So what you need to do is these are the export commands. So if I show you in a terminal what these look, not with the actual keys, we don't share keys. But for example, export Elastic Cloud ID equals, and then the particular value. Oops, I missed out an E, oh dear. So if we export that out, and then this is the Mac. Is anyone on Windows at all? No? Okay, so you'll see if you export it, then it's picked up the environment variable, because you can see by echoing with $, you're using Windows. Cool, so what you need to do instead is instead of export, you need to use set. So you would do, there we go. So for Windows, you need to do set instead of export. And that will set your environment variables. You're using Linux. Yes, Linux is same as Mac. Good question. Yes. So if you're Windows, you need to use set. If you're Mac or Linux, you are going to be using export. So you need to do that for the cloud ID with the parameters I've given you, and then the same thing for the key. Okay, is everyone good? Everyone's good. Okay. Right. So that allows us to specify the credentials and pull it in via Node.js from the process. So what I want you to do next is I want you to go to Elasticsearch.js, and we are going to complete this section here. So first things first, we need to take step 7 in the worksheet that we're working through. I need to specify the client. So we specify an Elasticsearch client using that Elasticsearch library that we pulled in before. So I've specified the keys, the API key and the cloud ID, and I'm pulling them out using the Node.js environment variables, process env. So that should pick them up from the running session as long as you're running the app within the terminal where you've just specified those environment variables, okay? That's important. Otherwise, it won't be able to find the variables and it might fall over. You also need to know the index. So we're all using movies Carly Richmond, which is totally fine. And then we also need to add in the implementation of the get recommendations function in the Elasticsearch, which is step number 9. We'll skip around a bit. We'll do this while we're here. So the things that we're going to have is we're just going to check the client's instantiated. Otherwise, we're not going to initiate a query because there's nothing to query to. And then in the query, because we're using JavaScript rather than another language like Java, one of the nice things is that the query DSL also being in JSON, which is what we're effectively passing back and forth when we're using JavaScript objects. Lamy, instead of using cloud, can you install on your local machine? Yes, you absolutely can. So if you wanted to run and do this against a local Elasticsearch, all you would need to do, oops, for anyone that's interested, is go to Elasticsearch and you can just download it. get it set up and running on your machine, and then where you have the credentials for your client here, you wouldn't have a cloud ID. I think you can either use you would use the URL option and either the key or a username and password combination. So Lemmy, I hope that answers your question, but the answer is yes, you can. Cool. Right, so we have our recommendations function, we've specified the query, and what we've also done is just a check that if the language is specified, that we'll manipulate our query and add in the match for the original language. And then we'll return the particular search. So this client.search will basically go off, get our results from Elasticsearch and return. So we've got our query logic, but we still don't have the function in the server. And we also don't have, as was pointed out before, the action for the click event. So what we're going to do next is we're going to add a new endpoint in our server. So you need to open up server.js. And then step 8 of the sheet, what you're going to do is add in a new endpoint. So by an endpoint in a Node.js server, this is basically when you navigate to localhost 3000 / and then something, this is the particular path that it's going to resolve to. So using REST, you would commonly have this for API development. So what we're going to do is firstly, we're going to add in the required dependency towards the top. So we tend to add our dependency management at the top of a JavaScript file, just for convention reasons, and so that it's easy to find things because they're all in one place. So you'll see that I've said we need the Elasticsearch utility, which is this file here. And then I've also added in that app.get /recommendations. And we're pulling out 2 parameters from a query. So we'll end up, when we trigger this, having recommendations, question mark, query equals something 20 useful, because it will be escaped, and language equals en when we go and trigger it from the front end. And it will basically call our server with those values, which we'll then pull out. We're decoding the query because there's a potential that people might specify a query with spaces and things. So the last thing we want is to not pick those up. We've got the language where if it's all, then we're just, this is what's called if anyone's not familiar with JavaScript, a ternary operator. So it's kind of like a shorthand if statement. So what we said is if the language is not equal to all, then we're going to pull it out and decode it. Otherwise, we're going to specify it as nothing. Then we're calling the Elasticsearch function. And then we're taking the collection response and we're pulling out the hits. And it's quite weird. I found this strange, but it's hits.hits because you can have potentially multiple queries if you're using a bulk request, for example. And then what we're doing is we're mapping it to only pull out the source object, not the other attributes we saw before, like the score. And then we're sending those in the response. So just remember to save that. And then we've got the server connection, we've got the Elasticsearch bits. The bit that's going to be missing is what we mentioned before. There's no function for that click event on the button, so it's still not going to work. So what we need to do for that is step number 10. So step number 10 does a few things. So I'm going to copy it in and we're going to walk through it. So within the index.js, we're pulling out the values from the document. So we're pulling out the query input.value. So this is the value in the text box. Then we've got another selector, which is not by ID, but it's by the attribute checked. So this will pull out the selected radio button and we'll get the value of that. And that value is these ones that are in here. So that means that it will pull out, for example, if you've got all selected, which is the default because it's checked, it'll pull this value out. So then going back to my index.js, here we're putting in a placeholder message just to show we're going to do something. And then we have a try catch block because if we have any errors coming back from our server, We want to try and handle it in a nice way. So then we are encoding the title query just to escape those spaces and things we talked about before. And then we're using fetch. So this is the simplest way to make a call in JavaScript to a server or another endpoint somewhere. And we're awaiting it because it's an asynchronous operation. So then we're pulling out the query that we've been given from the text input and also the language. And then we're awaiting the response as a JSON object. Then we are getting the container for our results, and we're specifying the inner HTML as basically all of the recommendations transformed into individual elements. And it's going to add those on one by one because we're making use of the map construct against the array. Is everyone with me so far? I know that was a lot to go through in one step.
Yeah, just you were mentioning like a worksheet or something with steps. I don't think I have that.
Yeah, no problem. No, you're fine. Let me find the worksheet.
That'd be grand.
Yes. Here we go. So that's the worksheet there. And then that code is step number 10. This one here.
Amazing, thank you.
Got it? Sweet. Okay, right. So now I'm going to say, because we've changed the JavaScript, we need to restart to make sure that it compiles our code and makes our changes. So run start again. And then if I've done everything right and not missed something, if I look for funny films in any language, recommend, you should, by this point, have results coming back. Has anyone not got results coming back? Okay. Someone's got, right, Farhath doesn't. Okay, cool. Farhath, if you open up your DevTools, so to do that, if you go into the 3 dots menu at the top, more tools and developer tools, and then check the console tab, there might be an error that suggests what particular thing can't be found. And we can try and debug that. It might be we've missed a step, or it could be that your credentials for the Cloud ID and token are not in the terminal and not being picked up. That's one of 2 things that's potentially not quite gone right. Okay.
So I've
Oh. Okay. Has anyone else got any other questions or any other issues at this point? We can take a moment before we move on to the vector bit.
so I've just got a bunch of stuff in my console from extensions. I can't really tell what's related to this.
Okay.
But feel free to continue. I'll figure it out at some point.
That's cool. Otherwise, we can connect afterwards, but there is a filter. So what might be handy if you've got stuff from extensions is if you look for stuff against localhost and filter, it might get rid of some of the other noise and help you focus on what's going on. So yeah, give it a try. If not, we can try and figure it out afterwards. Okay, cool. So now we're going to talk about vectors. There you go. So as you've probably kind of guessed when we went and did the basic kind of text search, one of the things that is a bit limiting with text search is that the terms need to match exactly. Otherwise, you won't get the document back. So for example, when we're looking for funny, it doesn't seem to have things that say comedy in there unless funny is also there. And that means that we might miss out on particular useful results. And we call that the vocabulary mismatch problem. The other issue is that we can only do text search with text documents. And, you know, in the year 2024, we have all sorts of wacky different types of documents that we want to search, things like video, images, And it's very difficult to do that with just text search. So, and the third thing is it doesn't really pick up sentiment or semantics of what we're talking about because it's that exact matching. So this is what vector search aims to eliminate. So rather than looking in the text for exact matches, we're doing what's called vector comparison. So if we remember back to our high school mathematics, which for me was sadly, well, thankfully quite a long time ago, basically what we're talking about is a multi-dimensional stream of numbers. And if we have all of our documents that are basically included in that particular vector space, we can then translate the query in the same way. And then we can therefore check the distance of our query against the documents to find the ones that are considered semantically close together, because we've used the same model to generate the embeddings. And we'll talk about the models in a second. So for example, if I looked for cartoon human and maybe the query is resolving around, maybe here, then that means that these two results would be considered to be close because of cosine similarity, because the angles are closest compared to these ones here. And therefore, those would be the results that I would consider to be more relevant than compared to, say, the direct matches we talked about before. So it's scoring the documents still, as we talked about before, but it's doing it in a slightly different way. So in order to use vector search, you need to convert your text into vectors. Now, the way that we're going to do that is using a model. So has anyone heard of Hugging Face before? Yes, wonderful. Okay, cool. So some have. So for those who haven't, that's a-okay. Hugging Face with the emoji, heard of it and never. Yes, it will be all over LinkedIn. It's all over mine as well, Cecilia. So what it is basically an open repository. Come on. That has machine learning and AI models and also data sets. So if you wanted to use an LLM, for example, so if you might have heard of Meta have got their own model called Llama 2, for example, you would go to Hugging Face and you would be able to use that model either using their inference API or by downloading and running the model locally in order to generate those vectors for our documents and then putting those into Elasticsearch. So called the GitHub of AI. That's probably one of the best descriptions I've heard for it. Thank you. Absolutely. I think that's a very fair point. I tend to see more AI discussion around Hugging Face and, the models and things like that are there. So yeah, I think that's a really good summation. So to make things easier, I've just uploaded this model before. There's a couple of ways you can do it, though. We've just done this for kind of shortcut reasons. And this means that the embeddings will be run in Elastic. But the other thing that we can do, which if I was doing like a personal project, is I generate the embeddings outside and then push the documents in. So what we're going to do now is we're going to see if we can generate some vector embeddings. Now, first I'm going to check if I still have the existing index from earlier. No, I don't. That's cool. That means I can follow the steps exactly. So to generate the embeddings, we're going to use what's called an ingest processor. And in simple terms, all that is ingest pipeline rather. All it is basically a set of steps to transform the documents that are in an existing index when you're moving them into a new index. So if I clear you out, so this is at the top and everyone can see, you'll see I've created this pipeline and we're using something called an inference processor. So what this is going to do is it's going to use this model, that MS Marco Mini LM, which is suitable for generating these embeddings. And it's going to generate the vector using the overview field. So it's basically going to take that overview field, translate it into a vector, using its algorithm, and then it's going to spit that out into a new field in our index called embedding. And if it fails, then it's going to set some error messages just to let us know. So what I'm going to do first is I'm going to create the index. The reason I'm creating the index is because Elasticsearch can be smart, and if you don't have the index existing, it initially, as we saw before, will try and figure out the types of fields. And I don't want it to figure it out because I want it to have a dense vector type. If it came back saying it was a number, because it's multiple numbers, then my vectorization is not going to work. So I've specified that it's a dense vector type, and the dimensions of the vector, which it normally gives you on the model, is 384. So we make sure that we match that. So I now have created this new index. And then what I'm going to do is I'm going to re-index my data using that pipeline to generate my embeddings as a shortcut. So that's where this command is here. So I'm doing a re-index, which basically means take all the data from this index and put it into this new index. So we're taking our existing one, and then we're moving it into the destination, and we're using that pipeline I showed you before. So if I do this, if others try it, this might go wrong. It will take a minute, because if you think about the computations of this, it's having to run a model to generate a lot of these 384 size dimension vectors, and then it's putting it into the Elasticsearch index. So that is going to take a while, because memory serves. What's an embedding again? No, good question. So an embedding is basically that vector that we talked about. So now that this is finished, I can show you. So if I pull this out, it's okay to ask this, because this got me the first few times I did this as well, Keshi. Yeah, so no, I want the results. Cool. So the embedding is this, basically. It is simply a stream of numbers that represent that overview field in our document. So this is the vector. Does that make sense? Cool. I can dig out some more resources that maybe go into it in a bit more detail. Yeah, I'll have a think. I can send those on to Kimberly afterwards. But yeah, so you'll see that it's generated this huge vector for each of those documents. So we can see those. Right, okay, cool. So now what we're going to do is move on to vector search and show you the difference. The closest the numbers are, the more similar they are. Yes, exactly. Let's go to Wikipedia. There are several different ways, depending on the algorithm. In fact, in Elasticsearch, you can specify different algorithms for comparing the similarity. But the default for comparing these embeddings, these vectors, is called cosine similarity. And it's basically the angle between the vectors. So it's the distance between them. So this here. So yes, exactly. The closer the document, the closer the vector is to the other one, the more similar they're considered to be. Got it. Perfect. Cool. Nice. So now we're going to compare these and see what the differences are. So everyone, I will put the queries back in. Everyone's feel free to do the querying at this point. We'll clear you out. Don't need you anymore so that people can see. Cool. So we've got the search. So first things first, just to show you that we've still got those original fields in this vector movie. So if I do a match on overview, you'll see that it does come back with results. So it's came back actually with a lot of hits, which I guess a lot of them might have terms like film and things, which makes sense. But this is what we call a semantic search query. So it's got context in it, if that makes sense. So if I asked you, you would know as a human that this is me looking for a recommendation for maybe comedy films or films that you've watched that you've found funny. But thinking about the vocabulary mismatch problem, this is not necessarily going to match. I mean, the first result is saying Barbie is a teenager. That's maybe not my thing now. Maybe when I was younger. Woody Woodpecker, but it does have laugh in it, so okay, that's maybe fair. That might be considered relevant. The wolf pack, I'm not sure that's necessarily the kind of thing, but you can see what I mean. It's not really picking up the idea of comedies so much in semantics, and that's why we use these queries called KNN. So KNN is the name of the algorithm that is for vector search, and it stands for K nearest neighbor. So what it's doing, going back to that diagram we had before, is basically that model that generated the embeddings that we saw for our documents is going to do the same thing for our query that we submit, and then it's going to try and find the nearest documents. So if we go back, I have an example query here, which should hopefully fit in the chat if people want to try it. There we go. So what we have is it's not query at the top this time, it's KNN. You specify the field where the embedding with the vector is. So that's this field, which we had as embedding, which you can see, yep, from that document there. We have the number of neighbors we want to return. So that's 10 in this instance. We have the number of candidates. So remember we talked about the idea of Elasticsearch and splitting into shards. This is the number of candidates that we're going to evaluate in each shard. Because if you think about it, the comparisons we're doing are computationally expensive. So if you looked across every single one every time, for large data sets, it might get too much. So sometimes you want to balance the precision of this with the performance. So that's where you would specify a number of candidates, and we'll play with this in a minute and see what it does when we start increasing it. And then we're basically saying that we're using the vector builder. So the other way to do this is if you had a vector generated outside, you would just do the query vector option, and then you would specify your vector here. But because it's all in Elastic at the moment, we use the vector builder, specifying the embedding. I'm using the model ID, and I'm going to basically use this model to generate an embedding for this text. And then that's what's going to get compared against the documents in the index. Is everyone with me so far? Yes, kinda. Okay. Would an example help, or yes? Okay, cool. Let's show an example and we'll see. If it still doesn't make sense, we can go back through it. Don't worry. So this is my results here. So it's shown I've got 10 results, which makes sense because I specified that I wanted the 10 closest candidates to come back. 10 closest documents, sorry, because if I use candidates, that's going to get confusing. So looking in the hits, you'll see that the first one, it talks about a stand-up special from Dave Chappelle. Okay, so that kind of makes sense. It doesn't have laugh in it, but it does talk about the idea of funny because it's a stand-up comedy. So that does seem quite relevant. The second result, not necessarily sure it's so funny or amusing, sadly, because it's talking about Tupac. Okay. There's one about Glee. So actually the third one could be considered to be funny. And then this looks like a romantic comedy that's come across as our fourth result. So it's quite interesting sometimes whether you consider it to be syntactically close or not. And this can be something that's worth tuning. So we can see some things like different things from Disney. So other those things that you might consider to make me laugh. So that's quite interesting. So now let's try and check number of candidates. Makes more sense. Thank you. Wonderful. I'm glad. Sometimes an example helps, doesn't it? Cool. So now it took 5 seconds for this to come back. Let's play with number of candidates and see what happens. So if I up this to 1,000, not much is really happening. It's still taking roughly the same amount of time. It's taking about 5 milliseconds. Okay. Now if I change it to 10,000, you see it's taking 6. So the more results we're evaluating on each shard, the longer it's taking, because it's doing more comparisons and then it's joining everything together. Now, what about when I go and change it to 100,000? Do we think this is going to work? Yes, you're right, it doesn't work. Do you know why? Yeah, it didn't work on your end. Aha, cool. So this might be a bit confusing. In the documentation, there is a hard limit of 10,000. So if you go higher than that 10,000 for number of candidates on each shard, it's going to error out. So that's why it didn't work. Cool. Got it. Perfect. Okay, so we're making good time so far. Is there a place we have to define the token? The token used. What do you mean by a token, Lemmy? Thanks for the heads up. I know where you're going, but I just want to double check. While you're doing that, I will bring up what I think you're going to anticipate. Yes, that's right. Tokens are the basic units of text that the model processes. Yes. So that's a different type of task. So if we go to Hugging Face, and there's the model search, you can see that there's all sorts of different task types. So for an LLM, it's text generation, and the tokens that you're talking about, you're right, it's basically the number of tokens it's going to kind of, it's the basic unit of process. Yes, anything like shingles. I'm not sure.
It's like, you know, when you look at a string of text, but you look at it in bits.
Yeah.
Yeah, bits of it.
Yes.
And not the whole thing in one go. Okay.
Yes, exactly. Because now you're getting to the limits of my knowledge, Lenny, so I'm going to apologize if I've got this wrong. But with an LLM, the way that it is that the tokens are basically a unit of processing, and it's according to what's called the context window. So one thing, this is actually an interesting discussion point, because one of the things that we haven't done when we did our when we vectorized our overviews is we didn't what's called chunk it. Because one of the issues you can have if you vectorize large documents is that you're skewing the kind of vector direction. And it might mean that potentially it's semantically similar to something that you didn't expect. So what can end up happening is you'll do something called chunking, which is where you split the document into multiple. And for vector search, that makes sense for potentially identifying the features of interest. But on an LLM, it's to do with the context window, which is the amount that it can basically remember and process at the time. So that would be the tokens that it's remembering, which it's then using to basically generate. It's kind of like, the only way I can describe it is like the attention span of a 4-year-old, if that makes sense. So let me, have I answered your question, or have I just made this completely more muddled? Okay, I think I might have made this a bit more confusing. I've answered. Cool. If you want to chat more afterwards, let me know. Can I share this link? Absolutely. Let's do this. That's it there. And if anyone wants to brush up on their cosine similarity, there's that link there as well. Cool. Okay. So now we need to do 2 more things before we move on to the RAG stuff at the end. So first, we're going to run some what's called hybrid queries, because you can combine these together, and then we're going to add it into our web application and see how it changes our results. So going back to our dev console, you'll see that you can actually combine these together. It doesn't always make sense. It sometimes gives you wacky results, but you can. So you'll see I've got my existing query that we did before, just a simple match. And then we've also got that KNN one that we did before. And you'll see that I'm getting probably some rather strange results. This seems to be a thriller. Doesn't quite fit with films making me laugh. So it's probably coming from this particular query here. The problem with combining queries together is that sometimes you end up with results that don't necessarily make sense. And sometimes you might need to kind of tweak and say, I want you to basically give a particular query higher precedence. And that's a process known as tuning. So the way that we tune, in simple terms, like manual linear tuning, nice, is that we add this factor called boost. And what this will do is that score we were talking about before, it will basically increment that score by the boost factor. And this can turn into a little bit of a game of kind of tweaking and checking and seeing if for the query it actually makes sense. So you'll see in this particular occasion that actually it's given me a sufficient boost to put Dave Chappelle's stand-up towards the top, which is kind of cool. But for example, if I'd maybe boosted it by a factor of 0.5, oops, hold on. There we go. You'll see that it didn't actually impact the overall result. So it can be a little bit of a guessing game. But there is another algorithm that you can try and play with that is aiming to blend things together. And it's called reciprocal rank fusion. And it basically uses that rank RRF option in the next query that I've pinged in the chat. So you'll see it here. So reciprocal rank fusion basically looks for all the queries in the group that you've combined together. And if the document's in the result, it adds to the score 1 divided by a constant plus the rank of the result for each query in the document. Okay. You can tweak this as well. So you can specify the constant, which is K, to tweak things, or the window size, which is basically similar to that number of candidates. It's basically the limit of the number of results per query that you're looking at, and it tries to blend things together. So the logic is that if you have the same document in multiple queries, that one will be artificially elevated because it appears in more places. Hopefully that makes sense. Use a data set to train a model. Very similar, yeah. You might try, what you might do is you would potentially, for that data set training, you would classify. So when you're doing query tuning, it is similar in a way. It's not exactly the same, but you would potentially have a set of queries that you would expect maybe to be commonly used or ones that you want to kind of benchmark against. And then what you would do is you'd say, these are the results that ideally I would want to come out. You would see based on the query and the tuning parameters what results are coming back. And then you would pick basically the boosting factors that would basically give you the results in the approximate order that you would want. Does that answer your question? So the tuning isn't really to use somewhere else. Yeah, exactly, which is why reciprocal rank fusion is intended to be perhaps more of a kind of default. It's depending on the use case, it's never going to eliminate tuning. It can help you have a rough benchmark to try against. But yes, it is the same thing with training. It's tuning, checking, as you say. Does that make sense? Cool. Great. Right. So now we need to tweak our code for the last time before we quickly visit RAG, where I'll just show you the code for the RAG stuff. So in step 5 of this other sheet, so let me pull this up so that you can all look at it. Sheet 6, you'll see the queries we've just gone through. And then this is the code that we're going to change. Okay, so if I send you this exact link to the sheet, we need to change our index and we need to change our query slightly. Okay, cool. So if I now go back to my code again, and this will be in the Elasticsearch file. So I am, there we go. Oh, hold on. I've done something wacky. There we go. Right, if we do something weird, we just start again. Okay, cool. Okay, wonderful. So we're changing the index we're using because we're using hybrid. We can't do vector search against the original one. So change the index to that vector movies Carly Richmond on line number 6. Should be line number 6, hopefully in your file too. And then in get recommendations, the thing that's changing is the query. So you'll see that we've got this query option and we've still got KNN in here as well. And we're still specifying the models. And then we're passing in this model text film similar to and whatever the user's added in. We have added in RRF as a blend, but we wouldn't necessarily need to do that. You could boost it if you wanted. And we're still adding in the language condition and we're still doing the search. So now if I stop, clear, and restart, and cross all the fingers and toes that I have, what we do, refresh the page. So films that make me laugh, recommend movies. You'll see that we're getting different results back. So it's blending things together. And actually, we've got some comedies in here. We've got Dave Chappelle's More Than Expected off the back of the blending, which is interesting. We've got Glee, the movie, which I think we can say there's some fun moments in there. Marley and Me's got a sad ending, so I'm not sure I necessarily agree that that film is going to make me laugh. But these are the semantic results that we've had come through. So we've built a semantic hybrid web app. Nice. Okay, so we have 30 minutes. Nice one, Celia. Has everyone got that bit working? Any other questions? Nice one, Kitchi. Okay, cool. So the last bit I am going to just show you. And the reason for that is that we're going to talk about large language models. And it seemed a bit unfair to ask you all to basically sign up for an OpenAI account thing. So I'll just show you how it works. If you want to go off and play afterwards or try out a different LLM and you get stuck, feel free to DM me afterwards. Happy to try and help you out if I can. But this extension is basically we're adding a featured review bit to the top. And the featured review is going to come from a large language model like Lemmy was talking about before. So what we're going to do is still pull out the results from Elasticsearch like we did before, and we're going to use that as the context for the LLM to generate a response. The default for OpenAI is it uses GPT 3.5, which is the kind of older version if you're on the basic. If you're on a paid account, I think you can use 4 and some other models as well. But one of the limitations of LLMs when you're running it against your own particular data is that obviously it's not been trained on that data. And that means that it can't really just go off unprompted and generate a response that makes sense for your particular case. So when we pass the documents as the context, then we're doing something called grounding the LLM and saying, we're limiting you to this scope. Please only generate within this scope and nothing else. Grounding, sorry, that's my pesky accent getting in the way. Grounding. There we go. Cool. I should be able to find a document. Right, so we're not going to get ahead of ourselves with the solution. So let me see, I can find something. LLM grounding. Here we go. This one I came across recently. This was a useful resource to have a look if anyone's interested in the details of that. So the things that are going to be different this time, if people want to follow along, if you navigate out of Starting App and you go into Solution App and RAG extension, this is where all the code is. Nice. So if I start this app, cool, I'm going to close all of this code. And then in my RAG extension, I'm going to open the same files that we've been looking at. So we need the Elasticsearch, we need the indexes, and the server is the same, and the package.json is useful. So starting off with the package.json. There's some additional dependencies we need. We're using a technology called LangChain here. Has anyone heard of LangChain before? Wait, installing dependencies. Cool. Cool, Lemmy's on it. Wonderful. So Lemmy is going to keep me right. But basically, LangChain allows you to, well, build chains for building RAG architectures. So what you can do is you can pull in source documents from all sorts of different sources, so not just Elastic, anything at all. You can do things like splitting them in chunks, doing the chunking stuff that we talked about before that we hadn't covered here today. And you can pass them into an LLM and you can do it all in one place and it makes your code a little bit more straightforward. Now, I am taking a shortcut today where I'm basically using the client and then passing into LangChain, but there is retrieval ways to use vector stores, and there's Elastic vector store that's been contributed by the community that you can use to chain everything together. But to keep it simple, what we're going to do is pull the results out using the client as we've done before, generate the prompt for OpenAI, and then we're going to get our recommendations back with our results. So to do that, we need LangChain, we need the OpenAI extension, and we need core because we need to be able to generate the prompt to send to the large language model. So the things that have changed, if I go into index.html, and I'll pull this down so people can see, hopefully the text is all right and it's not too small, but you'll see I've added in this featured container. And this basically has the results, the recommendation that's going to come back. Okay. Did I start in the right location? Yes, I did. Okay, cool. So that's the change in index.html. There's not much we're doing there. The index.js is where most and not much has changed, apart from when we get the recommendations back, we have this featured section and we're adding in the review. And that's in addition to the existing results of element. All of the change is actually in this Elasticsearch file. Okay, so the first things first, we're using the LangChain OpenAI to generate a client for OpenAI. You need an OpenAI API key. If you want to know how to generate one of those keys, see this lab sheets RAG extension folder. I have, if I show you the preview, there we go. I have all the steps in here on how to generate a key if you want to play with this afterwards. But for the moment, I have this loaded as an environment variable, the same that you've been doing with the credentials for Elasticsearch before. And then I've set the temperature. So temperature in LLMs is an indication of randomness because it's about whether it's kind of pre-caching or pre-restricting any aspects of the results when it returns it. So the lower, I might get this the wrong way around, so Lenny will correct me, but the temperature, if it's a value between 0 and 1, and the higher it is, basically, I think the more likely it is to be changing and being different between each time, which depending on your use case might be great. Or if you want something in an industry where it needs to be reproducible, it can be a little bit tricky. The next thing we want to do is I've just taken that querying logic that we had before, and I've literally extracted it out to a separate function. So that bit is not changed. We're still using the same Elasticsearch query that we did before. But what has changed is get recommendations. Once we get the documents, we're creating a prompt. So a few people had said, I think earlier, that they used or heard of ChatGPT. So when we all started playing with ChatGPT, when we started, you probably remember typing in the question you wanted to ask it, it would go off and then it would generate a result and return it back to you. So that question is the prompt. So here I've got the basic textual template. I've said create a movie review containing the title query that's being passed into the recommendations of the following movie synopsis. I'll show you which one that is in a minute. And then we've got the language as well if we actually add in the language. And then we're passing that in as our prompt template. So we can then change that by injecting in the values that we get back in from our API call. So you'll see here that title query is resolving to title query, language is resolving to language, and then the context, we're taking the first document that comes from our results, and we're passing in that overview object that we've been using before for our vectorization. You then use invoke against the chat model, passing in the prompt to get the response. And then we're returning two things this time in a JSON object. So we've got a featured review, which is the content of the messages that's returned back, and then the original documents, which means that we'll still have the original sources. So if anyone remembered using ChatGPT and it hallucinating and saying, you know, making up sources and things, one of the advantages of using this RAG architecture style is that you already know what the sources are because you passed it into the LLM. It's grounding it as our context. Okay, so moment of truth that this is going to work. So if I refresh this page, you'll see it's updated now with this featured review. Films to make me laugh. We'll just select all, we'll hit recommend. And this is where it would have been useful. There we go. It took a moment. Cool. But you'll see it's generated a featured review based on the film called The Blind Date. And then it's still got the recommendations underneath. Okay. Magic. Thank you. Yes, magic indeed. Cool. So if people want to go and try off that extension, just follow the prerequisites and you can generate the key and then you can give it a try. If you initially sign up, I think you still get some free credit that you can try it out and play with. And then the 7.2 exercise, that's actually all the steps to get the code changes in order to do the review. So we've got about 20 minutes left. I think we've been making good time. So we've covered vector search, semantic search. We've put them into our wonderful web app. And then I've shown you how to add LLM generation on the top. Has anyone got any questions they'd like to ask about any of the labs, something that maybe didn't work, or anything Elasticsearch, or anything at all, really?
So on the lab sheets, you skipped over a few of them. What else is in those ones?
Which one is that? Do you know what sheet it is?
Give me 1 second.
Is it the vector text search?
Yeah, I think so. So what else was in that one?
Okay, hold on. Yes, Kitchy, you've increased your... Oh, Kitchy's in... Yeah, you get an insufficient quote error. Yes, we'll talk about that in a moment. Yeah, so let's talk about those then quickly. So, okay, so we did this one. That was the vector movie search. We did the KNN query, and then we checked out the number of candidates. So we did do those. I wonder if it's in the hybrid maybe. So let's see the ones that we maybe skipped over. Okay, so we did that one because that's the initial combined one. So I think the section, is it section 2 and 3 and 4 maybe, where it's 2 and 3 where we're changing the boosting factors. I think that's the ones that you're talking about that potentially missed, but we can go over these again. That's fine. So no worries, Cecilia. Have a good evening. Thank you for letting us know. So with the boosting, let's copy it. So this one, we're just updating the factor for the query we had before. So this is these linear factors, the idea that we were talking about where you have to change them regularly in order to try and figure it out. Which one is the right factor. So initially we had a boost factor of 0.2, and then you had this boost factor of 10. Yeah, so originally it was 2 and 2, sorry, and then we changed the booster to 10 and seeing if we changed the same results. Then we had the reciprocal rank fusion. And then we move into adding it in. So I'm not sure. Have you got a particular query maybe that I've glossed over and we can discuss it?
I didn't fully understand the boost part. So what does changing the boost from 2 to 10 do?
So this is basically tweaking the score. So this is what we call kind of linear combination. So all you're doing is you're saying for this particular query, I want you to basically take that score that came from the original query, and I want you to add on a factor of 0.2, basically. So what you're doing is you're artificially inflating the score of that particular query because you're saying that this one takes precedence over the other one. So the logic of it is that if you have this one has a higher boost than this one here, that the vector search query for two documents that have the same score, but one of them is from the vanilla text query and the other one is from vector search, this one would end up with a higher score because you're artificially inflating it by an additional constant. Does that make sense? Can you boost?
Yeah, I think I kind of get it.
Cool.
I will definitely do more research on it to fully understand it.
There might be a section on just boosting, let me see, because that might explain it in a bit more detail.
Also, if you want to work on this, will we still have access to everything to work on it like during the week, or are we going to lose access?
No, I'm not cutting it down. So what I was going to do was I was going to leave it open for maybe a week or so. And if you want to try stuff, and then if you get stuck, feel free to DM me. I will be around at the festival on Saturday as well, if there's any other questions that pop up. But yes, I'll leave it open for a week so you can try it out as well. And if you need it for longer because you're playing with stuff, just let me know and we can sort something out.
Perfect. That sounds great. Thank
Cool.
you.
You're welcome. And then boosting. So that's the boosting construct, but if I give, right, I will dig out the documentation for boosting and I'll send that along with the other stuff. Agnes, to answer your question, boosting only one part of the query, you absolutely can. So if you're having the situation where you only want to boost one just by a particularly large constant, because that's the one that always wants to be priority, you can just boost one of them. And all you would do, from the examples that we have, is you would just take out the boost that you don't need. So if I run this, you'll see it's still obviously boosting by the higher value, but that's how you would boost only one part. Cool. Right. Do we have any other questions that we want to ask?
Yeah, I was wondering, do you have any advice on how to test an Elasticsearch query? Like you're saying you use boost and a whole bunch of mechanisms to like affect the scoring of the results, like every document.
Mm-hmm.
But sometimes you might change the query in a way that suddenly document that you think is relevant is not scored as well, or affects certain queries in a way. Like some queries might work better and some other queries don't work as well. And so how to put in place some sort of testing to make sure that, or is it even possible to make sure that when you try to improve your query, you're not making it worse in some ways?
Yes, no, I get you. So I guess there's two types of testing. There's the actual testing of the query itself, and then there's the testing of your application and your code. If you're doing the latter, there is ways to spin up, to either mock out the Elasticsearch client or also to spin up Elasticsearch in something called test containers, which is quite a common thing that my colleagues use, and that will allow you just to basically check that all of the parts are integrating. So if you were running it in that scenario, that's one way you could do it. But your question was specifically around, if I change part of the query, how do I know it's better or worse?
And in terms of relevance, I suppose.
Yes. So there is the profiling API, and there's also this particular search profiler, which you can play about with in Kibana. So can I find it? Profiler. Search profiler. So it's in DevTools. It's there. There we go. So if I hypothetically wanted to change the query and I wanted to see, maybe it's taking a bit longer than I expect, because when it comes down to checking just the results are what you expect and in the right order, that's really around having your benchmarks in place and then scrutinizing the results. So you could probably script up checking the results are what you expect. Is probably the way I would do it. Why are you complaining? Sorry. So this is the search profiler. You can use the API, but there's also this here, and this allows you to actually look at the performance and see what your query is doing under the hood. So if I add this in, you'll see that it shows you each segment, and you can dig into the underlying details. So you can see all sorts of weird and wonderful metrics. You can view the underlying details, and you can see how long each particular section is taking to come back as well. So in terms of like the performance, it really is and in terms of relevancy, it's about taking your sample queries and checking the results are what you expect. But if you're wanting to kind of look into particularly a query that's maybe running slow, then you can use the search profiler for that. Does that make sense?
Yeah, it does. And also, yeah, sometimes you have to kind of balance relevance and performance, where you want to try some really complicated, very specific query, but looks at too much stuff, takes too long, it's not worth it.
Yes, the other thing that you can potentially do is you can run multiple queries. You can kind of run multiple queries and then join them together. I've seen people do that when things have maybe not quite worked out the way they expect, and they can do additional filtering of the results. But I always tend to find that's normally a last resort. But yeah, there's quite a few different ways to try and handle that particular one. It's definitely tricky. Okay, how would you suggest I get started with training a model for a particular use case? Oh, so there's a couple of things you can do. My first suggestion is if you can find an existing model that will do what you want that's already there from a forum such as Hugging Face that fits the brief of what you want to do, that has, you know, conditions such as licensing terms, etc., that you're happy with. I would try that first because it's a much lower learning curve to try and use one that's already there than actually to try and build your own. If you want to build your own model, which you can, there's a couple of different technologies that you can look at. So there is TensorFlow is one of them. And you can use that to basically build your own model, and you can do that either in Python or JavaScript. And I have been playing with the JavaScript stuff recently. It's quite good, quite good fun. There's also PyTorch as well, and I think there's a couple of other ones. Thank you, Kimberly. So I would recommend having a look at those and potentially taking a look at there's something else. Your own model. TensorFlow. So yeah, so there's actually stuff online about how to build your own TensorFlow models from scratch. Just make sure that you're using the right. I'm really new as well. I've only started playing with this stuff recently, so it's nice to learn from each other. So have a look. There's some good tutorials out there. Most of this stuff tends to be Python, rather than JavaScript, but TensorFlow.js, if you're wanting to do web stuff specifically, you can do, there is a JavaScript version of the TensorFlow library, which I've been playing with. And in fact, if it is JavaScript you're looking at rather than Python, I can dig out a, flow, there was a course I found recently, that I'm trying to find. It was by Google on their YouTube channel. I'm trying to see if I can find it. Playlists.
Hi.
I
Hello. Can you
will
hear me?
find it. Yes.
Okay, I thought to just unmute at this point because I'm typing a lot, but what would you recommend, JavaScript or Python? Because I've been building using JavaScript, TypeScript in the backend, but for this AI building model side of things, I'm thinking of picking up Python as a second language, especially for this.
Yeah.
So what would you recommend? Do you think I should keep learning with JavaScript, or should I use this to pick up Python?
My honest recommendation is if you're wanting to dive into the AI ML stuff, the majority of the kind of well-evolved languages, technologies, and a lot of the data science stuff around models and data cleaning and stuff is all in Python.
Okay.
So I think as much as if you want to do machine model specific stuff in the browser, then obviously the TensorFlow.js would be the one I would recommend. But if it's for learning fundamentals and potentially moving into that route of doing more models and AI, all the examples are in Python. All of the ecosystem there is evolved in Python. And to be honest, the TensorFlow.js is actually a port of the Python. So I would go with the Python.
I see. Thank you.
You're welcome. Cool.